So in this video, we're going to look at how we can estimate the area underneath the curve. Here are some of the basic facts. If I had a speed-time graph, the change in the speed over time, i.e. the gradient, represents the acceleration. Speed times time is equal to distance, and this is an indicator that the area underneath the curve represents distance. Here, I needed to work out the area under the curve using 4 strips. And I've decided to model these strips through triangles or trapeziums because the area of the triangles and trapeziums closely matches the area underneath the curve. In order to begin, I need to calculate the width and all dimensions of the 4 shapes. The first thing to do in this case will be to work out the values of y at y0, y1, y2, y3, and y4. For each of the different x values at x0, x1, x2, x3, and x4. So for each of the x values, like when x is 0, I need to work out its corresponding y value. Well, using the rule minus x squared plus 12x, minus 0 squared plus 12 times 0 is 0. When x is 3, negative 3 squared plus 12 times 3 is 27. When x is 6, negative 6 squared plus 12 times 6 is 36. When x is 9, negative 9 squared plus 12 times 9 is 27. And when x is 12, negative 12 squared plus 12 times 12 is 0. I now need to work out the areas of each of the shapes. Starting with shape 1, I can see that it has a base of 3 and a height of 27. This means I can calculate the area using half of the base times by the height, and this gives me 40.5. For shape 2, it's a trapezium, and I can see it has 2 parallel lines that are of length 27 and 36, and the height of the trapezium is now 3. So to calculate its area, do a half of a plus b, so 27, add 36, and times it by its height, 3. This gives me 94.5. Now as we can see, shape 3 is actually the same as shape 2. 27 is the height of y3, and I'm still using the same y2 value. So shape 3 will also have an area of 94.5 through doing the same calculation. And likewise, shape 4 has the exact same area as shape 1. So a half times 3 times 27 is 40.5. Adding all of these areas together gives me 270. Now for this question, 270 is an underestimate. And the reason for this, looking at the graph, is that the area of the shapes that I have included do not include the green area that I'm shading in now. That means that the actual area underneath the curve is greater than that of 270. So 270 is an underestimate. Pause the video here and have a go at the question on the right hand side. When you're ready for the answer, press play. So with this problem, I want to split the shape up into 2D shapes that I can calculate the area of. Here, I've done exactly the same as the previous example. I've split it into triangles and trapeziums. Labeling off each of the sections, I need to work out the heights and all dimensions of each of these 4 shapes. So doing as I did before, working out when x is 0, when x is 4, 8, 12, and 16, I get the y values, which are 0, 144, 192, 144, and 0, using the rule y is equal to minus 3x squared plus 48x. For shape 1, I can see that it's got a base of 4 and a height of 144. So it will be half of the base times by the height gives me 288. For shape 2, it's a trapezium. it has one parallel line of 144 and the other, which is 192. So a half of 144 add 192 times by the distance between them gives me 672. With the symmetry of the curve, I can see that shape 2 and shape 3 are exactly the same. So shape 3 also has an area of 672, and shape 4 I would calculate by a half of the base times by the height, which would then give me 288. Now adding all of these areas together gives me 1920. And as before, this is an underestimate because the actual area underneath the curve is greater than that I calculated.